Hey everyone, Meteorologist Tuttle with you. It is about 10:20 or so on a Saturday morning. So we've had some storms that have been making their way through western Oklahoma over the morning hours. They've been below severe weather limits for a while. Then they're finally starting to get a little bit more agitated as conditions get a little bit more favorable. So therefore, they're starting to rotate a little bit more. So now we're kind of shifting now into kind of a tornado coverage mode as some of these may try to produce some. So thanks for joining me. We're going to go through all this information for you, kind of walk you through where they're at, give you the big picture, and tell you all who is in the path. And this is probably going to be one of several lives that I have to maybe even come on and go off of back and forth, just kind of depending on how things go in the atmosphere. Because it's not a deal where you get tornadoes the entire time. It's where one may try to spin up and then they go away. So I may sign off, sign back on, and etc. We'll see as long as Facebook behaves. It messed up on me again here a minute ago, and that's the issue. I had to do a double entry. Okay, so let's get on with the situation out there currently. So this is our storm that initially prompted the concern here across Oklahoma. So there's one that's up here near Fairview, and then one out here south of Visay and around Leedy, and then back in here towards Cheyenne and Radin, here into the eastern Texas Panhandle. So we're going to go through these. First, we'll talk about the one that's around the Leedy area. So it's let's click on this one. A tornado warning issued here a few minutes ago. Expires around 10:45, moving to the north at 45 miles per hour. Radar indicated tornadic circulation, again, not confirmed by a spotter. I am seeing some live views, and they're basically it's a nice wall cloud, very low to the ground. But so far, no official touchdown at this point in time. Leedy, of course, pretty much the next few minutes. Then we have Camargo, Visay, and Mutual coming in as this storm continues to kind of develop and move into that general direction. So we'll just track it little by little, and we'll take a look at the insides of the storm, and we'll see what it does as far as rotation center is concerned. We have a lot of products that we use on the radar system to look for rotation, because you may not be used to all this stuff. So hang with me. You're going to see all kinds of different colors on the map, and that has to be done so that I can track where the potential tornadic circulation would be. For this one right here, it's very, very weak, but it's also around 10,000 feet, so this is a mesocyclone view. One of the issues that we have out here in western Oklahoma is we don't have very good low-level radar coverage. So in other words, you get a lot of overwarning in this area because we can't see down at the lowest level. So it's one of those deals just to be safe rather than sorry. If we do look at the algorithms, the probability of a tornado within this storm is 10%. All right, so this is what the algorithms detect based off the current environmental conditions and what the storm has to work with. So we'll see. I'll keep coming back to this one, and we'll see how it looks over the next few minutes or so. This one up here around O'Keene, believe it or not, has a really nice structure to it. It's a little outflow dominated. At one point, there was a brief part of its life cycle where it started like it was going to get its act together. It's got a little trail here, so we'll see. This one may also turn to a position where they do issue a tornado warning here in the near future, so we'll keep an eye on that. Right now, the structure of the storm has to get slightly better organized for the hook echo to form. But regardless, it's a heavy storm up there in the Isabel area. Probability of a tornado is only 5%, so obviously quite low right now. But the change in the environment from this morning, there's a low cap out there. In other words, a lid that helps prevent severe storms from being rooted in the boundary layer to produce tornadoes. That's gradually eroding as we get more and more, daytime sunlight through the clouds, a little bit more heating. So that's going to help to destabilize things a little bit more. So although these storms were not in a very favorable environment when they first started, they may become a little bit more favorable, especially across northwest Oklahoma, as we go through the rest of the morning hour into our lunchtime. Here's some more activity, like I said, back here into southwest Oklahoma. I'm going to switch radar views so we get a closer look at these. Again, these are not tornadic at all. Matter of fact, these are still baby thunderstorms in their development. The main, most impressive one, again, is up around Cheyenne, and even then, it's still a little disorganized right now, based off of both radar views. This radar view is coming around 9,000 feet, so even for sampling a mid-level mesocyclone, it's still not that well structured. Typically, you would get a very well-structured mid-level cyclone before you get the tornado. But, we'll watch it here little by little. Probability of a tornado on the algorithm is still 10%. Now, the best way to use this little probability scale is on a ramping structure. In other words, does the number jump? Like, see, there's 10%. You can see it bigger on this map. Does it jump from 10% to 30%? Does it go from 30 to 60%? So that's kind of how you can tell whether or not, at least using this type of an algorithm, as to whether or not it should be about to produce a tornado or is weakening, etc. Not necessarily the number itself, because I've seen probably a tornado at 70% and there was no tornado, or even 80% no tornado. But I've also seen it where there was a tornado at 40%. So it's more of just a scaling, how quickly that number scales in one direction or another, as just a leading indicator. There's a lot of things that has to happen to get a tornado. It is not easy to develop a tornado, believe it or not. A lot of things have to happen just perfectly within that one particular storm, regardless of what the environment tells you that storm can do. Each storm is on its own. All right, so Oklahoma City. All right, so obviously things are quiet here. The forecast last night was discussed. Let me get my drawing map on here. The models had most of the action coming in to a corridor about like this. All right, and I mentioned last night that it could be a little off. It could be over here, or it could be over here. Well, it turns out it decided to pick this little slot right here. So that's why things are a little bit west of Oklahoma City here this morning. So if you have anything to do outdoors, again, we're primarily quiet right now. I do believe, however, by the time we head to like the 2 o'clock hour, I think we'll start to bubble up and break, some of that area of the cap. And I think at that point is when our window opens up just for off and on severe weather for the rest of the day through the nighttime. So it'll be a very long day. So if you do have outdoor plans here in central Oklahoma, again, I can't guarantee anything dry after about 2 o'clock. That's pretty much the maximum time limit that I'm comfortable with. If we do stay dry after that, great. You're just buying yourself it could be for a few minutes or an hour or two. I mean, you're not buying yourself a whole lot of time. But I know there's a lot of outdoor, events, and I understand that. So if you can squeeze them in, great. Just kind of keep an eye on radar trends. I'll be doing these live broadcasts off and on. If I don't just stay on here now, we'll see how it goes and play it by ear, okay? So that's kind of how things are looking right now. That's the quiet part. So you can see all these storms right now in the far western and northwestern Oklahoma. All right, so I'm going to go back, get a close-up view of my data here so I don't miss anything. Just make sure nothing's going to ramp up while I'm talking about it. All right, so that storm's still a little disorganized. And this one down here, same idea. Again, I've seen some of the storm chaser photos of basically a nice little wall cloud, very low to the ground, and that's about it. Let's see. Now, wall cloud, if you don't familiar with that, it basically looks like a bowl on the bottom of a thunderstorm, and it's very low hanging, and it usually spins like this. Sometimes it rotates slow, sometimes it rotates really fast, but that is where the tornado originates from. So if you're ever out and about, you see a storm like that coming towards you, you probably want to go the other way or seek shelter really quickly. Okay, let me see here. So that right now is a quick look at the radar views. I did take a quick look at kind of how the forecast trending was going. I've got a lot of things open here. So this is the tornado watch that is currently in effect right now. It's kind of on the low end of the intensity. So the probability of a tornado is about 60% indicated from the Storm Prediction Center in this area of seeing one, just one, in this box shaded area. And the probability of one strong tornado is only 20%. So again, we're not quite in the period of the day to where we're expecting those stronger tornadoes. These would typically be the weaker ones, unless some type of a freak thing occurred, boundary interaction, you get other cells merging. Sometimes that can kind of up the intensity a little bit, but the environment itself isn't as favorable as it will be until later this afternoon and evening. Okay, so let's look at that. Let's see, that was a discussion. So the tornado watch is pretty much all across the western third of Oklahoma. All right, in yellow, does clip the Texas Panhandle there. If we do look at the surface map, we have a south-southeast breeze. Again, anytime you have a kind of a southeast or easterly wind component going into thunderstorms, it does help for tornado genesis. They like to have that southeast wind because the winds aloft will turn from a southwest or westerly direction after the fact. Let's see what else I'm going to show you. Let's do the satellite viewpoint. And I think I'm going to give you the water vapor to show you how this is progressing. All right. Okay. Let's see here. Oh, I know what I did here. Let's take some of these off. It's a little too many map things on there. Okay, what I want to show you here is the storm system that's coming in here from the Four Corners area. And the leading edge of this is the first jet streak coming in to round out the bottom and kick in. This is coming in across western Texas, right? And then on into southwestern Oklahoma and the Panhandle. So this is what is kicking off the start of our storms. Now the issue here is that this whole area does generate lift in the atmosphere. In other words, broad lift in the atmosphere. So in theory, as long as this lift continues, which it should, and it continues to migrate across central Oklahoma and western Oklahoma, we will continue to be under broad lift, which does mean additional showers and storms will develop. And again, these storms that do develop will be quite severe. But that's kind of the big picture to make it easy to understand. Is that's how it's kind of starting now early and how it should continue to progress. All right, so let's go back to the radar maps just to make sure we don't miss anything here. Again, we're looking at the storm out here in northwest Oklahoma, up around the Leedy area, moving to the north at about 45 miles per hour. Still watching a few of the storm chaser views. It's just a real low wall cloud. There's no funnel. There's no tornado with it yet. Again, if you are in this area, you always seek shelter at the lowest level of the floor, away from all outside walls and buildings. So if you're upstairs, go downstairs. So the circulation center is passing between Morewood and Leedy. Let's see, right about halfway between the towns on Highway 34. So that's where your wall cloud circulation would be on that one. Let me go to another radar view. Let's see. Look at it from a different angle. So yeah, this little yellow line here is the track. Now the track will change. So for example, when this warning first came out, the track was going like so, all right? Now as the storm rotates more, which means it kind of turns to the right, we now have more of an easterly track. So what that does is as that storm starts to turn more to the right and more instead of less to the northeast, northeast, it starts going maybe northeast or east. That means the storm itself is turning to a hard right, starting to rotate a lot more, which indicates the potential for a tornado to develop. And usually when that happens and the tornado does develop, it's a lot more of an eastward movement from the storm. Probably of a tornado, though, is still only at 6%, so we're kind of watching to see if this thing does develop into one. It's one of those deals, just kind of wait here and just kind of watch it little by little. Again, as far as the radar is concerned, for the strength of the mid-level rotation is very, very weak. So usually when that happens, you do not get a tornado until that strengthens and tightens. Okay, so let's see. We've got the one back around northern Oklahoma we looked at before. It was still trying to get its act together. Looks like the Weather Service has gone ahead to issue a tornado warning for this one. At this point in time here, it looks like the Hook Echo is trying to get a little bit better organized with an inflow notch in this pattern. So basically what they're doing is they're staying well ahead of it. In other words, there's two ways you can do this. You can kind of wait for good confirmation, or in a situation environment where you don't mind if you overwarn and it doesn't produce a tornado, because obviously the opposite's not good, then you can just be proactive and issue a little ahead of time, even if the storm doesn't tighten up to produce the tornado. Now, in the probability scale, it's gone up to 17%. Remember earlier, I think it was 5%. So this is the ramp up as I talked about. The direction here is kind of on the east to northeastern path. So Ames, you're in the path of this particular storm. Let's give you a storm track on that. Let's see, which one am I on? Let's go this one. Okay, so let's see. All right, so this one's moving, they got it east at 23 miles per hour. Radar indicated is a developing potential tornado. Max hail size 1.75 inches. If we track where the area of the tornado would be, that's Ames here in the next 10 minutes or so. And then we have Drummond after that and Wilcumas after that. Probability of a tornado still, like I said, is at 17%. Hail size up around an inch and a half in diameter. Let's see. Let's close that one. I'm going to switch radar views so we can get a closer up view of this one. So it still has a linear look to it. In other words, there's no gate-to-gate shear. There's no strong core of velocity data, which indicates a tornado at any point in time for right this second anyways. So we still have some time for it to develop. So again, an aim, just stay in your shelters until it passes. So basically it's kind of in that developing stage. And it may not. Just keep that in mind. I will let you know that even though you never discard a tornado warning, not all tornado warnings have an actual tornado with them. It just means that conditions are right. The storm may do it, may try, it's getting close. There's a lot of those little variables in there. But obviously the point is not to issue the warning after the fact, is to beat it, right? And give you extra time just in case. So that's why you get a lot of warnings versus confirmed touchdowns. And that should tell you something. Let's say I'm gonna give out just a number. It's not, I didn't look it up, on the statistics side, but let's just say, for example, out of every 10 tornado warnings, only 2 actually produce the tornado. All right, so I'm just throwing that out there as an example to let you know how that works. Okay, let's go back here to the leady one. So basically over this guy too, on the north side of Leedy, it's wrapped in rain at this point. It's probably occluded. But this is your mesocyclone circulation center that we're looking at. And let's see here. It's about 50 mile per hour winds outbound and only 20 inbound. Very slow rotation, so not very fast on the wind speeds. That one is moving to the northeast at 25 miles per hour. Tornado warning expires at 11:15. So about another 30 minutes before this particular part of the storm is out of this polygon. And then they'll issue a new polygon that'll take it further from there. And then we can do the latest path on that. Well, it's already, let's see, there's no other communities that's affected right now at that speed. Let's see, doesn't have a good look to it as far as producing a tornado right now. So that's good. It's just a cluster of cells without a very strong mid-level cyclone area. I still see the live shots. It's got, for the wall cloud areas, very, very slow rotation. I mean, painfully slow. When usually that's slow, that's not enough shear in the atmosphere. That wind has those clouds really have to spin really fast. I mean, it's almost like a carousel, right? And you see it going around. You have to see it with your own eyes doing something like this rather quickly. If the clouds are sitting here and they're just kind of just moving like this real slow, that's not indicative of a immediate tornado genesis. So visually, that's how you would differentiate the two, because we do get a lot of wall clouds around here. Okay, let's go back to the Ames area. I'm going to analyze this with a couple of different radar views. So this one's still linear. Still has a long way to go for producing a tornado. Probability at 23%, so it has gone up. Let's see, the one down here, probability is at 7%. It's in the forward flank position of the storm. That's like a little data contamination. Let's see. our wind profile in the atmosphere here in Oklahoma City is south, 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 and eventually kind of turns southwest. Now, this is typically not enough turning with height at a very short level of the atmosphere to really get those storms to rotate quite hard to get the tornado to produce. All right, so remember, we're early in the game. Our better shear comes in later this afternoon, not here this morning. So when I mentioned my post last night, I had stated they should be mostly elevated, thunderstorms. So in other words, there was a weak cap in place this morning, so slightly elevated was the wording, with some hail and wind. I said I don't think it'll produce a tornado, just in case I'll watch it, just because I knew we're kind of on that borderline where they'll have a tough time to do so. Now the afternoon is a completely different story, but here for this morning, but it's now 11 o'clock, so we're getting, remember, every hour we get into the day, we're getting closer and closer to the afternoon. But this is the primary reason, and so far this is panning out. New development down here, around Childress area and back here into Texas. So again, like I said, that gravy train of moisture and instability will continue to feed this area. So we'll get additional storms, looks like, just off and on here throughout the course of the day, and those will gradually shift east and affect central Oklahoma as well. If you missed it earlier, I can't promise anything longer than 2 o'clock as far as it being dry here in the metro. The data hasn't been very helpful as far as timing goes in the overall look as to how the system will evolve. Most of the time, this is pretty clear. This one was really muddy, really murky. It was frustrating because I like to give you more specific details on timing and exact areas, but this system is just, it wasn't behaving properly. So even our highest resolution models were having a tough time discerning on how to deal with it. All right, so if you're joining me just now, we're just watching a couple of tornado-warned storms. There has not been a touchdown. In one case, it was a visible wall cloud, fairly low to the ground, but very, very slow rotation. The structural for both storms was not where it needed to be to produce a tornado, and the velocity data in the mid-levels of the atmosphere was not very strong. So in other words, the mesocyclone itself is very weak. So so far, all that's good news. If you don't want a tornado, that's kind of what I'm saying. But we're going to sit here and watch it because it's in an environment that should gradually improve with time, and we'll see if that does change. So if you are in the Ames area, that wall cloud looking structure would likely be pretty much right on top of you at this point. Just make sure you stay in your shelters until it passes overhead. Let's see here. Yeah, we don't have a good ZDR arc or a cross correlation coefficient. So it's neat. Modern research in tornado genesis has learned a lot in the last 10 years, and especially in the last 5. I mean, crazy amounts of revelations are coming out. So, for example, this is a supercell, okay? And we're looking at it. On the left side is reflectivity. On the right side is velocity data. This panel right here on the right side, I change this to ZDR. All right. Now, for me to be able to see if a storm is ramping up to produce a tornado, I look at the edge of the reflectivity and I match it over here on the ZDR. Now, in the ZDR, I should have this whole area bright red, kind of like this spot up here. This should all be colored in red, right? And it's not. So we call that an arc. But when that does happen, it basically just means there's a change in the size sorting of raindrops from big to small, which indicates a lot of processes from updrafts and downdrafts to start to get a storm in the ready to produce a tornado. So in other words, we watch for that as a key indicator, as a signal in the radar data. We've got a lot of different things that you can use to try to track whether or not a storm will produce a tornado. This other one is this little basket of ingredients that I have here on the screen with the probability of a tornado at 38%. Now that's been going up, and that's what started off at 5, then it was a little higher, then it was a little higher. So the ingredients that this storm has to work with And the way the storm is getting structured, the algorithm is getting more and more favorable, but it's still quite low. But again, I like to see it ramp up a little faster than that to indicate more of a signature. All right, we'll keep our eye on that one. Let's go back here to the Leedy, Camargo. So that storm has kind of rotated northward through Camargo, the old rotation. It's rain wrapped. It's in this little slot right here. Very, very weak, diffuse. So again, this thing never did produce a tornado, and it's lost its structure. It has a little bit of a kind of an S shape to it. All right. So there's a little mid-level circulation here. So this has to go through a complete metamorphosis to get back into a position where it can produce a tornado, and that may not even happen. We'll see. So what will happen is the Weather Service will allow this warning to expire, which let's see, when does this thing expire? At oh, it's been canceled. Okay, well, there you go. Well, even better. So that one's been canceled because the system just fell apart. This one here is set to expire, what do we say, 11/15. So this one they'll probably just allow to stay and just sit because the warning's already there. So when that happens, even though it's not producing one and it's not even close to producing one, it's kind of like once you trigger it, you can't take it back because then that confuses people. In other words, if you were to take it back and then 5 minutes later you put it back out there to cover the same area, it doesn't make sense, right? So you just let it ride. The only way that you would cancel the warning is if the storm had completely fallen apart and there was no chance at all of any regeneration. Otherwise, you just let it go and you let it expire and you just don't issue another one. And then you watch the storm for a while and then you'll issue one if the storm looks like it's going to rotate again. And this one, like we said, has still got a long ways to go to do anything remotely tornadic. But again, never disregard the tornado warning. Always be in your shelters. So let's go back here to the big picture here. Moving to the northeast at 25, or 26 now, updated. And let's see here. Movement, we'll take it to Drummond, here about 11 o'clock. Enid, 11:24. Fairmont, 11:42. Breckenridge, 11:43. So as you watch this coverage, be sure to share it on your social media so your friends and family that are maybe out doing stuff today can at least tune in remotely, and that way they can be advised of what's coming and what's happening so they're not caught off guard. All right. Path on this guy, so it's becoming more of a linear base. Let's see, through 11:30, so about the next 35-40 minutes, there's no other major towns or communities involved. In other words, there's a lot of open land out here. This is open farmland. So the next community would be right about 11:30 for Sealing and Tologa and up toward Putnam even after that, if it even clips you at all. All right, so again, nothing here in Oklahoma City. This is watching storms moving in from western northern Oklahoma. Let's see here. I'm going to do analysis on this storm. Let's see. So this little pink area you see here, 20,000 feet, that's some hail aloft, rather large, so we're talking golf ball size. But it is very limited. In other words, when you get storms that are much more intense, you will get hail cores, lofted something like this. You know, this whole thing will be pink. When that happens, now you have a massive hailstorm with a lot of big hail. So we don't have that with this. We do have some hail in there. It was very, very limited in coverage. All right. Well, I'm looking for stronger levels of mid-rotation on this storm. I don't have it. So this is my velocity look to it, okay? In other words, I look at this just so I can ascertain how strong the storm is. So I can look at this in a three-dimensional view. Here's a rotation product we can use, which is kind of a derivative of the storm relative velocity. And when we typically see a column that goes up like this of the blue and greens associated with it, then that's our good rotation column. So even this is pretty weak. Okay. So this storm still has a long ways to go to produce a tornado. We do a play motion of this. A lot of times you'll see little tags or scud or hanging things from a storm. They're just cloud features. Like, it's nothing that's anything concerning. A lot of times people are mistaken what they call scud for tornadoes. And scud is basically this rising motion that condenses. So in other words, there's so much moisture in the atmosphere and lift that as that moisture comes up, it basically forms a cloud on the way up, and it's a darker cloud, and it's because it's in an area where there's not much sun, so it's a shaded area. All right. Okay. You can hear little Penelope in the background. There's a big truck outside. Okay, so if you guys are in Enid, obviously you know that you are now in the path of this particular tornado-warned storm. So you need to be making your precautions and you're executing your plans to seek shelter to anticipate its arrival. Let's go back up here to our time of arrival. So we've got about 15 minutes or so before the storm starts to affect you. still outflow dominated, so the RFD is still the dominant feature of the storm. And as long as the RFD is dominant, you can't get a tornado yet. Dominant outflow is something like this, where the winds come out of the storm. What happens is, in that look, if it's too strong, it messes up the circulation center. So this has to weaken a little bit, and then you can start to get rotation developing as a result. So this is where we'd watch here. So again, if we take just this track right here and we move it, in this fashion, assuming it doesn't go to kind of a more of an eastern turn, that would move through North Enid. All right. So this particular tornadic part of the thunderstorm, should it develop, because right now it's got that little circulation center with it, North Enid here, again in the next 20 minutes. So that would put it over, let's clear that out. So that's like North Cleveland Street, West Phillips Avenue. That would kind of be the intersection of where this would be. So this tornado warning, they got issued a new one to join the southern one. Hail size up to 2 inches in diameter. Storm motion northeast at 28 miles per hour. Keep my phone charged. That's going to be going off a lot today. Okay, that reminds me. I had to do this for the wife. All right, because she's not from around here, right? And she's wanting to know, when you say tornadoes, do you mean us? Are we getting tornadoes? Kind of a deal. And I'm like, well, in other words, our house, is what she's trying to say. It's like, look, I can't, science isn't that good hours away, right? As in 12 hours, 8 hours, 6 hours. We can do that, though, when it's within an hour, if a storm is heading your general direction. And then we can do it within, one scale of minutes, for sure. But she's trying to understand that conception so she knows how to mentally prepare and plan, right? So I said, look, just pretend we're going to go to a hotel for a couple of days on a mini vacation. Pack a small suitcase, some clothes, toiletries, pills, credit cards, driver's license, all that kind of stuff. And what we'll do is we'll take it with us in the bathroom. We'll put it in a little travel carry-on, in the bathtub. And that way we're covered. Because you always think it's never going to happen to you, right? That's your brain. Your brain always tells you that, it's not going to be that bad. And so you don't prepare or plan as a result. So that kind of, if you plan, then you're good, Whatever happens after that, well, it's out of your control. You were able to do what you could control. Probability of a tornado on this one's 51%. So in other words, that number continues to increase. So that does mean the storm is still trying. All right. Let me do some deeper analysis back on this one again. So yep, there's our circulation center right along Highway 132. About 2 miles south of Carrier on East Road 0390. Again, that'll pass south of the Kremlin area and on the north side of North Enid. Again, a tornado warned storm. No official tornado. It's still disorganized in that aspect. Up to 2-inch size diameter hail. Let me see. What about the one here around Lenora? Let's see what happened with this. Leftover circulation is Sestos, west of Sealing, looks like. Very, very weak. And looks like another very, very weak circulation around Lenora in Dewey County and just south of Tologa. But it's embedded in rain. Probably just little vertices. Nothing tornadic. All right, and then again, you got the new development continues back into the eastern Texas Panhandle. Nothing here over central Oklahoma. Some new stuff up here in Blackwell, Ponca City area. Just some baby showers. So in Kansas, if you're up in Kansas, these storms will be crossing over the border here in southern Kansas in the next couple of hours. Okay. Still additional storms down here in Texas that's still firing up all the way back. So that is an indication that we will have what we call a gravy train, so to speak, of thunderstorms that will continue to develop in this corridor and expand. Now they will have more of a northeastward component with them as we go through time. So we'll look at the newest model data, but what that may mean is that for this wave that comes in for this afternoon, it may start kind of in this area, right? So just west of Oklahoma City. And then we'd eventually get storms bubbling up on top of us anyway. And then some of these, if they decide to be hard right movers, would then cross over the typical path and move in this fashion, right? And those would be tornado producers. So that's kind of how this afternoon should evolve from this morning. Okay, so back to our storm here west of Enid. Still struggling. Yeah, still struggling. So there's something missing. There's something that the atmosphere doesn't like up here. Let me look at the wind shear. Odds are there's probably still just a good cap in place in that area. Let me see here. Okay, so our wind shear linear from the south does start to turn a little bit more southwest by 7,000 feet. It does have a southwest component. All right, so we're looking at here to here. All right, so that is, if you do your angles, if you remember your geometry, so that's about 40-degree angle here, and probably about another 10-degree angle here. So overall, you're looking at about 50 degrees of turning in the atmosphere from the surface up to 7,000 feet. That's borderline, just for tornadic storms. It's better if they're 60, 90, 100, 180. The more you have these vectors, let me do this for you. Say, for example, 7,000 feet, our vector looks like this. Okay? And at the surface, maybe our vector looks like this. All right? So if you're swinging that around, you're swinging this all the way around to this point. That's a much larger angle of where these storms rotate around by the time they get from a southeast direction to a southwesterly, westerly direction. And that, when you get to that type of environment, you're in big trouble. All right, those storms are they're strong beasts. They're massive. So the better turning you have with shear, the better those storms can rotate, bottom line. So, and you have different environments because there's always a mixed case. Sometimes you can have, good directional shear, but you can have weak speed shear. And that happens a lot of times in the summer. All right, you can have winds at 10, 15 miles per hour, but you got great directional shear. In the winter, in the springtime, you can have sometimes very little directional shear, but speed shear is off the charts. And so there's a tornado distribution from all these different, categories, and there's always outliers, right? So I just gave you basically 2 outliers, and then everything else is in the middle of the statistical distribution, the bell curve. So right now we're on a outlier for right now. Doesn't mean it can't happen; just means it's very difficult. Probability of a tornado has gone down 31%. Let's see here. What we will watch for. What we'll watch for is this storm goes from here to about this position here, okay? We will watch to see if any of these little showers get stronger and then feed into it about this time. You can get little cell mergers that can sometimes then help to create the tornado. So we'll see if that ends up panning out. Okay, back out here in western Oklahoma. Again, these are just severe thunderstorm warnings, typical wind and hail, standard stuff. Nothing tornadic. Let's see. Let's change this. So we got an Enid. You can still breathe easy. The storm is knocking on your door, but it is not producing a tornado. It has a very linear structure to it, so therefore is weakened and lost a lot of its organization. Still though, stay in your shelters until it passes. So I was watching one of the helicopter shots from the Enid area, and it's just a very slow, converging base of a thunderstorm with some scud underneath. And it's just an inflow area, so there's no rotation within that. Let's see. Up here in Pond Creek. So on that northern edge of this linear structure, it goes like this. At the very northern fringe of it, in the forward flank, there is a little bit of a rotation signature here in this little spot. We'll see if that ends up doing anything. Let's see, was there a boundary there? Let's see what happened. Huh. There's some enhancement in this area. So sirens are sounding in Pond Creek as a result. Probably somebody saw a wall cloud in this little spot that I talked about. There's some type of boundary interaction there. All right, that's along the Staff Sergeant Chris Hake Memorial Highway, US 60, and also the one that runs out of 64 out of Pond Creek. That little intersection is where that's located, about a mile south. So if you live in Pond Creek, there's not an official tornado warning for you, but because of what shows here on the radar, you might want to go ahead and just be in your shelters, just in case. It's very weak circulation, but it is there. And obviously somebody saw something visually to go along with that for the local emergency management to sound the sirens. Either that, or they're looking at radar like this and they think, well, we better sound the sirens. Either way, it's not a tornado warning from the National Weather Service, but just let you know that's what's going on. Again, Enid, you're at the tail end of this storm, not producing a tornado, never did, but stay in your shelters. It's almost past you. So if you're in Jefferson, Pond Creek area, you're either sightseeing to see what's out your backyard, or you're going into the shelter, or you're just going to wait. Either way, that little area of circulation is in your backyard, in your area. But it's very, very weak. And it may never do anything, but just letting you know that's what that is. It's this little, there's my little circle here. This guy right here. And that is 1, 2, 3 miles southwest, west-southwest of Pond Creek. Let's see. See any highways in here? The old Farnham Market roads, right? So that's East Road 250 and North Road 2890. So up to about golf ball size hail. Okay, so some new data's come in, and that little circulation center is already kind of weakened. So what's left of it will be over Jefferson here about 11:25, probably 11:24. I see the TV guys have finally picked up on that. You guys are late to the party. All right. Probability of a tornado is at 22%. So the official tornado warnings have expired this particular area. So there are no tornado warnings anywhere across the state. Just that little baby circulation right here, southwest of Pond Creek. And when I say baby, I do mean baby, like little bitty, itty bitty witty. Nothing very aggressive or impressive. But that is a little area you're probably seeing some type of lowering visually. So what we're going to do, I'll give you a quick round tour of kind of weather conditions and the forecast for today, and then what I'll probably do is sign off, and then I'll just kind of watch things, and as things get a little more unstable in the afternoon, these storms should have a better opportunity to try to produce tornadoes than what they had so far. And then I'll, of course, be back on then that way, because I'm going to have to obviously take breaks at some point, or I'm a human being. I do have needs. So I do have sustenance requirements and other requirements that must be done. So off and on, I'll probably do that for today, because it's going to be a long day and a long night. Anyway, this little convergence zone up there at Concrete. I wonder if the, let me see something. Shear axis. Yeah, it does show up. Yeah. This little shear zone right here. This little highlighted area. Road 2900 and 81/60/64. That highway changes names 3 times. Coming westbound out of Concrete, though. Okay, so we just crossed over it, and newest data here has now moved it to 230, Highway 230, just west of 2910. All right, just a little nudge in the data, but again, nothing that says tornadic. It's just a little circulation center, very, very weak, but you might see some type of cloud feature with it. Okay, so let's see, I think that's it for now for the storm coverage. Let's shift in to forecasting, and let's see here what I got for you. Okay, so as we mentioned before, turn all these off. The upper level low, which is right about here, centered here, and it will continue to move kind of in this fashion. So kind of a little jot by 6 o'clock tonight here. All right, and out ahead of it, you do have our jet that comes in, right? And so the specific jet brings in the moisture and what ends up being little disturbances that rotate in the flow that come in to help trigger enhancement in the cloud shield and also help provide those thunderstorms. So you can see those thunderstorms are developing all the way back now here into this part of Texas. So these will continue to basically come this direction. All right. And because we're locked into this southwest flow aloft, that means as a storm moves this way, it moves this whole thing with it, right? But it's very slow progression. So in the meantime, everything that forms in this channel keeps moving over the same area, over and over and over. And that is how you end up with flash flooding. And that's why we have flash flooding as a very strong worded outcome in this event. Okay, so again, tornado watch in effect in yellow for all these counties. This is Oklahoma City right here. So Woodward, Enid, all northwest Oklahoma, Weatherford, Clinton, Elk City, Altus, just southwest of Lawton. All you guys are in that tornado watch. Will this be expanded east? You betcha. Just a matter of time. We do have those. It's a green area. That is the flash flood watch that is in effect. It does come up to include the metro. I can tell you when we look at data here in a minute, there is a argument as to whether or not most of flash flooding is east of I-35, or if we happen to get some flooding right here, maybe just a little bit west of I-35, of the metro. So we could easily see flash flooding here in town. Let's see what I want to see now. I'm just going to look at a bunch of little different indices. For this morning, the probability of if a tornado were to happen, for example, what strength is it? In currently the atmosphere, the way it's predicting, it would be a 27% probability in this corridor of a E of 0, possibly EF1 tornado. What about a probability of an EF2? 1%, 3%, 4%. So you see the difference. Our atmosphere is not quite ready for something stronger. And if you're talking about like a probability of an EF4, it's 0. There's no probability. So for the morning hours, we're with the weaker potential tornado should it even happen. And we've watched it struggle. It's just not happening. If you do look at the areas for potential tornado development, it kind of favors those zones where the current storms are at. When you look at what they call atmospheric tilting and stretching of the environment, in other words, how the supercell or the storms, how much they're sheared, what angle do they rise? Are they straight up and down? Are they really leaned over? And then what influence comes in under that? This is kind of bullseyed around the current area of development. Let's see here. Using just shear in the atmosphere itself, again, favors the same areas. A lot of these little different indices for tornado prediction. Right now, that's where they're all at. This is a real-time thing, by the way. So in other words, this is we call it meso-analysis. So you look for this to highlight areas that are of interest and concern, environmentally speaking. And we, for example, when we do take a look at the environment, so let me go to this supercell up here in northern Oklahoma. All right. So we have to check off the boxes. Do we have all the ingredients for severe weather? Well, STP, which is the significant tornado parameter, it is well within the little red line. All right. Our vertical is where we are in the atmosphere. The red line is all prior cases, in other words, how it compares. The supercell composite parameter, sure, it matches both of those. Cape values, oh yeah, it's in there. Effective shear, it's in there. Effective helicity, yes, barely. And your lifting condensation level, in other words, the base of your clouds, barely makes the cutoff there. But this is for all tornadoes. So in other words, the atmosphere says that you should have enough ingredients here to be able to do so. Let's go to a significant tornado. All right, significant EF2 or greater. In this environment up here with that storm, it's still in the box, barely, but it's in the box on this one for the tornado parameter and the supercell parameter, barely. If we look into the cape in the middle, doesn't have enough effective shear. It's on an outlier for a whisker. Let's see, for effective helicity, also an outlier in the whisker, and for the lifting condensation level. So for a significant tornado, doesn't have quite the ingredients to get something that strong, and therefore that kind of jives with that prior map I showed you about the probability of seeing something, right? Hodograph, very conducive, however, for rotating storms. And if you look across this area, these are all the data points that chart is based on, right? So these are all tornado tracks in and around that region. And it samples the environment from all those different past events, and it compares today's current event with those past events to try to then correlate your probability of, seeing the same outcome. So I use this a lot when I do my live discussions. Okay, let me look real quick at that storm up north. So the Weather Service took that area we looked at around Jefferson, that little mini rotation center, and went ahead and did issue a looks like a tornado warning for it just now. Pond Creek, you guys are getting some strong wind. This is the RFD. So as the air comes down on the back side, you get a nice blast of wind, and algorithm here has got some really strong damaging wind, about 100 miles per hour. That's impressive. That came out of nowhere. Probability of a tornado has gone up to 60% as a result. All right, so this storm then got interesting. Real quick. You know, it had that boundary interaction it was going over, and I wonder if that was the key. So let's go northeast at 41 miles per hour, max hail size, golf ball size. Like I said, it's over the Pond Creek area. The leading edge to Deer Creek at 11:46. This is Deer Creek in northern Oklahoma, by the way. Bremen at 12:04, Honeywell 12:05, and South Haven after that. So let's take a look at the velocity data. This is very close to the radar. Let's see here. And our value, 60, 70, 80, 100 miles per hour. Good grief, man. Let me see what height that is. That is at 1,100 feet, so 1,100 feet altitude. So you got to cut out about 10% of that value, at least, maybe 15. So with that in mind, you're probably getting 90 mile per hour winds gusting that went through Pond Creek and elsewhere over this area. It's along road 2940, again Highway 60, 2220. Now remember, this is kind of like having a small tornado. And there has been, looks like, some damage as a result. So this is the clear correlation coefficient. In other words, we use this as a debris ball indicator for tornadoes, but really all it does is measure is non-raindrops. So that means that this wind is legit, and it did a lot of damage, and it kicked up a lot of stuff on the ground, is being kicked up by the radar and then sampled, this little blue area. So that means that 100 mile per hour winds may actually be turning out to see a lot of that hitting the ground in that zone. So Pond Creek, now you guys are probably already in your shelters from earlier talking about that circulation feature. Probability of a tornado has gone up to 61%. So again, you'll need to still stay in your shelter until that whole system passes by. Medford, you're on the far northern fringe of that. You're about 2 miles north of that little indent circulation center. It's the straight line winds, though, that are wrapping around the backside are the strongest. And right now, those are moving on the east side of Pond Creek. Let me look at the view here.
All clear. There are no storms present in your vicinity.
Yeah, there's a very strong mid-level circulation within that storm. That's what this rotation track is here aloft. And so that's what's causing that air then to come down. That rotates around the backside and it comes right out the front underneath it. Okay, so that's that three-dimensional view of how that air comes down from the back end. Let me see. Probability of a tornado still 61%. It was very low. Okay, so the that blue area we talked about at the surface, when you look up aloft, it only goes up to about 1,000 feet, right? So it was detected about 1,000 feet less. If it was tornadic debris, that blue area would be like this. Okay, that's how it would look on radar. So that's how you know it's straight line wind. Basically, it just came in, it's knocked a bunch of stuff off that went out straight in a certain layer of the atmosphere that got caught here at the lowest level by the radar beam, and that was it. So just to get an indication of some damaging winds in that area. That's what that little blue area there was. So again, that's we call the tornado debris detector, but really it's just a debris detector. All right, so there you go. There's a confirmation that straight line winds can sometimes do as much damage as a small tornado, a weak tornado, because we had winds detected up around 100 miles an hour. All right, those winds aren't nearly as strong. They backed off, but they are still strong. Medford, you're at that northern end, little comma insertion, so you have this little weak circulation going through your town right now. Stay in your shelter for that. I bet all the damaging wind is to your south. If we look here at the wind speeds, 50, 60 miles per hour, 70. So obviously that's quite a bit different than what it was a minute ago. I'm going to put this in motion. We'll see how this evolved.
Attention. There are storm cells present in your vicinity.
Okay, so watch. Let's do this. Okay, so you're going to focus your attention on this little comma head right there, right? Now, as that comma head moves northeast, watch how on the back end of it, this little patch of wind just kicks up right there, right over Pond Creek. Right there. I mean, literally right over it, just coming into the city, in and out, and then it's gone as far as that huge damaging wind area. So that's probably a pretty good example. We often focus on the tornado threat, right, of a supercell thunderstorm. But you have to understand that straight line winds are very significant as well in that type of a thunderstorm, because you have a very strong rear flank downdraft, which is what was experienced here in Jefferson and Pond Creek. And that can do as much damage as a tornado, even though it wasn't a tornado. And the difference, let's just say, for example, this is a tornado in Medford right now. It's not, but let's just say, it's very small. It's on an order of a few hundred yards at most, right? What we just saw here, let's see, let's go this. Let's see, right here. Let's stop it right here. All right, so from, let's see, do I have a, okay, from here to here, all right, that was 100-mile-per-hour winds. That is almost a 6-mile distance, right? So when you're talking about a tornado with 100-mile-per-hour winds on the order of 100 yards or 200 yards, right? We focus so much on that. And look what really happened. You had 100-mile-per-hour winds over a 5-mile area. That would be almost equivalent of like having a 5-mile wide tornado kind of a deal. So, you have to still respect both ends when you're dealing with wind in that situation. Okay, let me clear that back off. So again, that wind has calmed down quite a bit, still about 50 to 60 in some of these areas. The tornado algorithms kicked up, I believe, because of that internal wind. There was something that excited some of those algorithms as far as the values that are concerned, because there's so much shear that was coming out of that RFD. Let's see here, but the residual circulation from Medford is just on the north side now, about 2 miles. Okay, so Deer Creek here, about the next 10 minutes. And then you got Honeywell and South Haven till about noon. The tornado warning will expire at 12:15, moving northeast at 41, max hail size 100 golf balls. Oh, this is interesting. Okay, let me see. We're going to keep our eye on this guy here, okay? All right, so now that this has such a really good mid-level circulation within the storm, when this guy comes in and gets entrained, we're going to see what happens. We're going to see if that's a little extra kick it needed to produce a tornado. So in the next 10 minutes, we'll have our answer. And by then, this storm is going to be way up here in northern Oklahoma, west of Blackwell, west of 35, coming into southern Kansas. Okay, real quick look at our storm down here. Looks like it has a little bit of a wind appearance to it with some hail. Not too bad. I think these values are doable. 50. Okay, it's not bad. Let's go back up here. Luckily for us, for this instance, the radar system was very close, so it's right here. So it was only, a few miles away, so we were really able to sample that storm really well to pick out those damaging winds. Yeah, this thing's really gusted out. Doesn't have nearly the wind with it as it did before. We're going to see what happens when these two merge. This one's catching up to this one. Alright, let's see. So while we wait a few minutes for that, by the way, the tornado warning that was on there has been dropped. So it's just as severe, looks like, at this point. This one needs to clear. Let's see, southwestern Oklahoma. Still got more storms there. All the big stuff is up now in northwest Oklahoma. Let's see. So Medford, a lot of heavy rain and some hail. Hail's not that big though. Storm's about 40,000 feet tall. It lost a lot of its mesocyclone strength, mid-levels. Alright, storm reports so far. What's this? Oh, $50 size hail in Ringwood, Major County. And then back out here. Dewey, ceiling, golf ball size hail. Okay, so let's check this throughout the day today to see as the severe weather reports come in. Okay. This storm has lost so much of its structural integrity. It's going to be interesting to see if this does anything as a result. It may just completely just convolute the whole thing, and then it's got to reorganize, and it won't happen until it's in Kansas. If it still had somewhat of a little hook echo on it or something with a pretty good, decent mesocyclone structure, it might be a different outcome, but it's a little messy. Let's see, what else I want to look up here. So Dallas has a big cap today, but it's smaller, I think, than what it was this morning. Anyways, that's why you guys aren't getting storms down in Dallas, North Texas, because your cap is too strong. Tulsa, you guys have just a little bit of a cap today, not much, hanging on by 1.5 degrees. That's tiny. So that means the cap strength here in Norman then is probably also tiny, but enough to keep stuff at bay. Rotation tracks on the map here, well, did show our storm. There they are. Off and on with that little system. Let's see, are these guys up yet? Nope. Let's see here, what about you guys? Alright, so our warn-on forecast has been started. Our warn-on forecast is a very short-term, high-resolution model that takes existing storms and moves them forward in time and predicts how they will evolve. In other words, it'll pick out the ones that will produce the biggest hail, the ones that will produce tornadoes. Of course, it's all a probability game, but using the best ingredients of everything it has to input from our atmosphere that we can do with all these local sensors. So when this thing gets populated, we'll start to use it as guidance. The Weather Service uses this as guidance to issue their outlooks, discussions, and warnings, etc. All right, so let's see. The latest HER keeps this little storm in Enid. What does it do with it? It goes north and evaporates. Okay. The one out in northwest Oklahoma goes due north and still hangs in there. The one southwest of there takes its place and gets going. They kind of all cluster around the Woodward area through 2 o'clock. Then there's storms here at 3, and 4, 5, 6, 7, 8, 9, 10, 11 o'clock tonight, midnight, 1, 2, and 3. So this is a squall line that this model is now projecting that starts basically, 8 o'clock, 7 o'clock. So it doesn't have individual supercells. It has basically just a big multicellular hybrid cluster of storms, all right? And then it kind of line echo wave pattern goes into a long progressed squall line development. Now within this, you see these little kind of a bowing structure, so indicative of damaging winds. Little helicity tracks right here and here indicate embedded supercells. So again, you can still deal with a couple of tornadoes within that situation. And of course, you always have hail, flooding rains. Little helicity tracks continue down here. Then that new wave kicks in around 1 o'clock in the morning. Tulsa's getting hit also. Helicity tracks with it. So in other words, this is the comma shape of the squall line, so there seems to be a lot of shear focused in this part of the state at 2 o'clock in the morning. And then that moves east. So it's interesting. And honestly, that's probably the best thing that could happen for us. And you're like, well, what does that mean? Well, you see how these storms here, the look to them are individual, isolated. I mean, there's still some that are kind of clustered. But this is more favorable for tornadoes versus this. All right? A squall line by nature is complicated because there's so many updrafts. There's so many individual cells fighting for the atmosphere, fighting for attention. They don't get to have what they want. They got to share with their partner. It's a lot of multicellular nonsense. And that helps to limit the tornadoes in many cases, both in intensity and in numbers. So honestly, if we were to get just a long-lived squall line, that may be the best outcome we would have, and you end up with a lot of flooding rain, unfortunately. So there's a downside to that. But anyway, so that right now looks like this particular model is where it's going, and that is our, up until now anyway, our best one. We've got a couple new ones they're working on. Let's see what the RFFS did. This is supposed to be its replacement, and it's got work to do. So look what it did today at 2 o'clock. So it keeps that stuff up in northwest Oklahoma and doesn't see anything else. And then at 1 and 2 o'clock just explodes the whole western part of the state with all supercells, with all these little helicity tracks. So see what I mean? It's far worse outcome to have a look like this than a squall line. You know, that's 4 or 5 o'clock, and then it's got the squall line that comes in at 7, 8, 9, 10, etc. But this model hasn't been proven yet, so it's still under development. Let's see, anything else? This guy came in just now. Let's see what he's doing. Alright, so this has the morning stuff. And it has the new stuff. See, here's 2 o'clock. This model has stuff popping up here in central Oklahoma at 2 o'clock. And then down in southwest. Just a lot of just cluster of storms everywhere. Probably because, I can't see the forecasted cap strength with this one. But because it doesn't have helicity tracks with it, makes me think that the model thinks that we still have a cap in place and they're slightly elevated, which limits the tornado potential. But this is, again, another experimental model, so I still have to learn its biases. But that's what the data is suggesting. Look at this other one. They have 3 physics components of this model. So they're running it with 3 different versions of physics that are slightly different. And the second one has a very similar outcome. I just wish you could get point forecast sounding so I could at least see what the model is thinking. You can only infer so much. Let's see here. Okay, what? No, it's the wrong date. That's not even running. Okay. So let's go back up to our northern storm. So let's see, the cell merger hasn't quite happened yet because makes sense. So the northern one, remember, it was a little bit more, I think it was more anchored into the boundary layer because it had that really strong rotation with it, and obviously we had the wind, damaging winds of the surface. It had kind of more of an eastward movement there for a while. Well, once all that kind of diminished and the mid-rotation died out, it started to take more of a jot to the north, which means now it's above the boundary layer, it's not rooted, elevated. Well, that one here, this one guy here, was also elevated. So they're now working on the same path in tandem. So now they're moving at the same speed, which is not going to allow this storm to merge with this storm, at least here in Oklahoma. You see how now they're kind of lockstep and barrel? So that's how things can change. So I need to use this as a learning experience for you guys when you hear there is a threat of tornadoes, all right? And they say, oh, we're gonna have, let's just say the forecast is you're gonna have tornadoes on Saturday. The atmosphere, look at all these maps I'm showing you. It is loaded. Look at these soundings. Look at this, that, and the other. Oh my gosh, these storms have tornadoes. All right. Now put that aside. Here's an exact example of where, look how hard it was for this storm to try to produce a tornado in, quote, said tornado environment. Didn't happen. Very difficult. Now, it did something different. It produced some damaging winds, but it never produced the tornado. So, tornado prediction, it's great to have, you know, the environment side of things. However, that means nothing if the actual storm in that environment cannot get what it needs and interact the way that it needs to produce one. It's not easy. So I want you to use this, especially if you're new here, when you do hear tornadoes in the forecast a lot, you know, over the course of spring, that, yeah, the environment may support it, but does not necessarily mean that particular storm is going to be able to do it. It's not like all storms will produce tornadoes. It doesn't happen that way. So this is a good example of what happened in this particular case. All right, let me see if I have any other wind. This has got a little wind with it around Waukita coming in on the forward flank of it. Nothing huge, standard stuff, 50. And our guy up here, not much with that one right now. Okay, let's go down here. Major. Okay, so this one will bear some watching. So you see how it has this little look to it, this little S-curve. All right, this means you have an inflow in this part of the storm, and you have tail end action coming in that might be slightly elevated, especially if this can get elevated. That would mean this slows down a hair, starts to move more to the east, and that'll allow this to run into the back end of it, and then you can kick out some tornadogenesis as a result. Now that could happen on the order of the next 5-10 minutes, or it may not happen at all. But it's going to take a little while to have all of that occur. So we'll look for trends to see if this guy goes in that direction. Outside of that, that's the only game in town for right now. Let's see. Let's look at the couple of the fun deals here. Wind shear, gate to gate. So there's your little somewhat signs of rotation area. And that's on North Road 2460 and 480. Probability of a tornado is only 7%. All right, Cleo Springs at 1216, Ringwood 1230, Mino 1236, Lahoma 1245, Goldtree 1246. And that's for this little area here that may eventually produce a tornado. So therefore you guys now have some warning. That doesn't mean it's going to, just means that's one favorite area that it could happen if, again, a lot of things happen to make it so. All right, let me look at the storm here in some detail. By the way, hail sizes on these storms, 1 inch seems to be pretty common. I see a few golf balls, but honestly, the hail cores have not been strong with these. In other words, the pink areas inside the storm have not been, going way up here aloft. They've been really low level. So that means the updraft strengths are too weak to push them up here to grow. You gotta get those hailstones way up here and get them to recycle, and they grow larger and larger and larger. But you have to have really strong updraft for that to happen. And because they're basically hanging down here at the bottom, that tells me that updrafts are weak right now. You need a strong updraft for a tornado. Now it does have an overshooting top. So this is the top of the thunderstorm. If you were to visually see it, picture this as white. And you see this puffy cotton ball on top. That's called the overshooting top. So the overshooting top is where your updraft is. And that is where your tornado gets anchored. So it basically kind of forms down into this area at the lower levels where you get your mesocyclone. It's because all the wind rushes in to this area from the ground and then hits that and goes right up. Okay, so we gotta wait a little while to see if anything comes of that. It's not happening now. Let's check on this guy coming into Kansas. So let's elevate it so it's moving fast. All right, so there's no threat for it looks like for either one of these. We'll have to see if this one does anything. Like I said, it's the only one that even has a chance, and it's got some time before it even gets close. Let's go check out the southwest Oklahoma, and then I'm going to look at some maps. Let's see. Yep. Okay. All right. So where do we leave off? Because then I'm probably going to sign off for a while. I'll wait. Look at a couple maps, and we'll see if anything happens of this guy. Let's see. So where do I want to go? I'll tell you what I want to do. Let's do this. So the forecast, or the balloon sounding from this morning in Norman, monster cap. All right. So when we looked at Tulsa, there wasn't much of a cap left. We should have similar air, although they may have been a little less capped than we were in the morning. We have to infer because we don't have a data point for them. But still, that was a significant cap. And then Dallas also had a significant cap. So that's why you guys and we, Oklahoma, weren't getting any storms. It's because we're just too capped for the first part of this day. Now, the cooler air that came in from western Texas my trough axis, which helped initiate those storms this morning, no cap at all. See, this line is almost straight. So that cooler air, see these winds here out of the southwest, that's an advection direction, right? That's a vector. So these winds, southwest vector, from this little point here on the map, is coming our direction, right? That's a cooling temperature. Okay, so let's see. There's the satellite instance. So also on the satellite instance, you can see overshooting tops when you look at the infrared. And when you look at the infrared, usually the brighter the colors, it indicates the colder the temperature, which means the stronger the storm. So we had a pretty good cloud top up here for a little bit, and we've had a couple of cloud tops here on these guys. Once you get one, like lone supercell, for example, that's just going nuts, you know, and it's got a tornado, it'll be a much smaller version of this whole thing, but it'll have a one big deep red area right at the top, or you know, maybe even a different color, to show how strong and tall it is and how cold it is up there. Let's see. Okay, so Storm Prediction Center Outlook. Let's refresh this. Okay, this was posted just 20 minutes ago. Okay, so they keep us in a moderate risk of severe storms. This is the tornado outlook, which is right here over central Oklahoma, right? So it's a hatched area, higher probability, 30%. Hail, big area here in purple, and wind also. The discussion, let's see, well, that's an old discussion. 756. Where's my new one? I'm gonna have to go to this to those guys themselves. Looks like. All right. Yeah, tornado is 15% rather hatched. So what that means is a hatched area is a 10% or greater probability of an EF2 to EF5 tornado within 25 miles of a point. So that is a significant severe situation. Okay, so let's read what they had to say. Severe thunderstorms are likely today and tonight across the southern central plains. Yada yada yada. The most numerous intense storms are expected from North Texas and Oklahoma and southeast Kansas, where strong tornadoes, very large hail of 2 to 3 inches in diameter, and damaging winds of 60 to 80 miles per hour are all possible. A regional outbreak of severe storms is forecast for this afternoon and evening across parts of Kansas and Oklahoma. Very large hail and strong tornadoes are possible. Water vapor imagery shows the main upper trough is still back over southern Arizona, with a rapidly ejecting mid and upper level jet streak nosing in Oklahoma, Texas. I showed you that on the water vapor loop earlier. This lead feature has aided in the development of severe storms this morning over parts of western Texas and Oklahoma. Storms will develop northeastward through the afternoon into central Kansas. Despite an expansive anvil shield from the morning convection, these storms will pose a risk of very large hail and a few tornadoes through the afternoon and early evening. Meaning, when they say expansive anvil shield, what they mean is the more clouds you have, the less sunshine gets to the ground, right? So you have less solar insolation, therefore less heating, less destabilization. So in other words, it's typically a stabilizing effect. And they're saying that that will not be necessarily an issue. Further south, and that's Kansas. Further south, the air mass across much of central and western Oklahoma and Texas continues to warm destabilize as temperatures rise through the mid and upper 70s, eliminating the cap, aka the sin. Only weak upper forcing through the afternoon will result in chaotic development of discrete supercells in a very strongly sheared and very unstable environment. Forecast soundings show very steep mid-level lapse rates, ample low-level moisture, and strong increasing shear profiles throughout the day. Details of timing location are nebulous, but those storms that develop will pose a risk of very large hail and strong and possibly long-track tornadoes. So 2 things there that you should pay attention to. One is nebulous, good word to use. I use the word frustrating because as they said, same thing. The models are all over the place with a solution, so let's quit trying to get too detailed and let's just look at the big picture and not get lost in what doesn't matter in the minutia. And the other thing they stressed is strong and possibly long-track tornadoes. Historically, tornadoes don't last that long. They can be in the order of seconds, they can be a few minutes, but rarely are they 30 minutes or an hour or an hour and a half. Those typically occur more likely, say maybe in the deep south, southeast. We don't usually get those type of long track ones, so they're a little more rare for us, but they're saying that's on the table. The stronger large-scale forecasting will arrive around and after dark, with an eastward surge of storms across central Oklahoma expected. This may organize upscale and bowing segments and squall line activity, with an increased risk of damaging winds, along with hail and tornadoes into southeastern Kansas and northeastern Oklahoma tonight. All right, so that's the whole recap from the Storm Prediction Center. Okay, let's go back over here to our Fairview storm, see if anything's changed. Still linear structure, north-south. There is a little weak circulation center on the northern end. Which looks about right. When you have that enhanced reflectivity with the gradient down like this, it's usually what that means. It's still extremely weak, though. It's not a rotating, severe weather, tornado-producing, damaging wind thing yet. Still very, very weak in its early stages. But that would be the area to watch, but we've kind of already discussed that. Because, again, if this thing strengthens, then it can pull in those strong winds on the backside, like what happened earlier with the other storm. Okay. All right, let's go back to where was I? Our data. Okay, so the Weather Service will launch a new balloon sounding, by the way, I think at 2 o'clock today. Oh, just for, whatever purposes, the AI model still has us centered here over Oklahoma for tornadoes on the left, hail on the right, wind in the bottom panel. So this is also another model. This came from last night. It had the bullseye of the tornado probability right around Tulsa, stretching back to Oklahoma City, and then here in southern Oklahoma toward Lawton. Basically, the I-44 corridor is what this one favored. Let me see what the new data has shown. That was last night's interpretation. So, where are we? 2 significant. All right. Okay. So this AI model called NATOcast, it's been around for a while, does fairly decent, just outlining the area. Has a 45 hatched region here. I have never seen this model go this high for tornadoes since I've been watching it off and on over the last year or two. So obviously this is concerning. So the AI model is really going crazy with tornado potential. The black hatched area, by the way, is a 10% chance of an EF2 tornado. Let's see, can you see? Yeah, you can't really see that scale in the bottom right. You can barely see it. Let me see if I shift this up. There you go. Now you can make it out. Black hatched area is 10% chance of EF2. And your color scale here, 15, 30, 45. It only goes one more, 60%. So that's obviously pretty ominous. Let's see here. The SIP for the Sea Wasp. I don't expect it really to say anything different than it did before. Let's take a look. So 85, 80, 85 through tonight and shifting off to the east. Anything over 65 is where you have significant tornadoes. So we have plenty of contours for that. Let's see. Partial sounding launched by Nestle near Weatherford. Cap is not much of an issue. Expect instability, shear, and moisture to only increase through the afternoon. Let's see here. 74 degrees, over 63. Yeah, a teeny tiny baby lid I mean, by the skin of its teeth. All right. So we have obviously some research crews out in Oklahoma storm chasing with their Doppler radars and their sounding platforms, which is good. Kind of gives us an idea of the atmosphere. Let's see what else we got. All right. This is the significant tornado parameter in the model data for tonight. So this is 7 o'clock, right here over Oklahoma City, for example. In other words, so all of central to west central Oklahoma is in this area where the atmosphere is primed for strong tornadoes. The spot that I picked here was a max in the data. Obviously some large hail, damaging wind signatures, basically barely a cap, if any at all. Really good shear profile, good photograph. So it has a EF4 on the category of effective layer. And again, these are whisker box plots, which they don't typically verify, but it's just a guidance based off all these indices of what the atmosphere could do. I often rarely see it do what it could do, but it's there. The one here in Oklahoma City, for example, this is the one centered right around Norman. Same thing. It's got no cap at all, and a lot better turning with height and shear than I was showing you earlier. Tornado hazard, it's in the pink, which means it's basically over EF4. Ship models 3.0, should have large hail over 2 inches in diameter. Analogs go up to 4.5. Obviously plenty of shear. Mean vector storm relative wind is at 100 degrees. So basically almost an due east wind feeding into the storm movement. And the storms themselves moving from the southwest to the northeast at about 45 miles per hour, maybe even 50. So some quick moving storms. Unless they rotate hard and produce a tornado, then they'll slow down and they'll move more to the right versus moving northeast. Anyway, so that's around here. Let's see, let me go back to that. That was that's 7 o'clock. Oh, for example, let's come back. So there's noon today. All right, noon today. Here's 4 o'clock, 7 o'clock. So you see how the parameters increase. In other words, that's why I was saying that the afternoon and evenings far better suited for tornado genesis than this morning stuff. All right, here's mid-evening. Here's midnight. So still a high amount. And these values are actually transposed here. This just when the model generates storms, it'll erase these things erroneously. And then it dies down from midnight to 3 a.m. There's still some here, but I can tell it's already dwindling. So that means the severity will after midnight quickly diminishes. The tech model. Let me see what this thing did here this morning. All right, it has that stuff this morning. Okay, and it's got new stuff this afternoon down in southwest Oklahoma at 1 o'clock, 2 o'clock, 3 o'clock, 4, 5, 6, 7, 8, 9. There's Tulsa, southern Oklahoma. 10, 11. All right, this is not a squall line look. This is a still individual supercell based outcome with clusters, storm mergers, helicity tracks galore. If we look at the helicity tracks alone, see all these little red lines? So that's all potential tornadoes, large hail, damaging winds. There's a big cluster there in western half of Oklahoma through our afternoon. And then for the evening, it still has some here in central Oklahoma and in southern Oklahoma. See, there's one. But not nearly as many, right? It's still going to have some, and the data doesn't finish going out here past, 10 o'clock, 11 o'clock. So So we still have a couple hours to see if it produces some more. But maybe that's a good trend where the tornado part, peaks from mid-afternoon to late afternoon, and then primarily dies down for the evening, although it still has one here and there's one down there. So that's a trend, right, in the data that we look at. Let's go to flooding. Let's see how the models differ. Yeah, there's 8-9 inches of rain, south side Oklahoma, from Oklahoma City southward. And then even out east toward Muskogee, Tulsa. Look at this little thin band. That's where you have that training, right, of storms, one on top of another. And the models won't get the training exactly perfect. They'll be the ballpark, but that's the kind of rain we could be getting. Icon model also favors that, excessive of 6 inches. There's a NAM, completely flipped on the north side of I-44 versus the south side, but same idea. The high-res NAM, in other words, it's little brother, but the little brother is the better version of it. It puts it back south. So the same model flips. That's incredible. Regardless, it's got big rain down here in southern Oklahoma. RFFS, 11 inches of rain. Good grief. UK Met, 7 inches, 3 or 4 here in Oklahoma City. If you blend them all, take a conservative approach, still 1 to 2 inches here in Oklahoma City, and then you have a pocket somewhere up to 4 and 5. That's conservative, by the way, which means that's going to be not actual. We'll get more than that. So flash flooding is going to be a big problem tonight from Oklahoma City south, north, and east over a large area. By the way, here's a look at tornado intensity, because we do mention tornadoes a lot, and then I'll look at radar here in a minute. EF0, EF1, those are the most common of all tornadoes. They do very light damage. Moderate, just some shingles moved off, some trees, about it. EF2 is what does some significant damage to homes, along with the EF3, but they're still standing, they're structurally sound and intact. That's why you want to be in the middle part, not the outside wall, because they can be breached, or the roof, or upper stairs, because they can be obviously breached and or removed, but the lowest floor is still standing. And then when you get to the EF4 and 5, which again, like I've told you before, this is together, they make up 2% of all tornadoes, and that's mostly for the EF4, which means the EF5 is like a point something. And this is like a once every 10-year type event. So again, we keep them lower in these deals, which is good news. All right, let's go back real quick with the radar. Let's see. Let's go this one. So that one in Kansas, like I said, just a cluster of elevated nonsense, so no big deal. Has a severe thunderstorm warning on it. This one here is not doing much. This one here, still the one to look at. It's taking its sweet time, but it is starting to get a little better look to it. Has a little RFD on it, but that is taking shape to be something that could become more tornadic. Hail size has also gone up to 2.3 inches in diameter, which means that the mid-level structure of the storm has strengthened. Probability of tornadoes at 13%. Let's see, on the wind field side, still nothing to shake the stick at. Let me go up higher. Nope. So winds are still behaving, even though the storm structure reflectivity indicates a little change in development. Yeah, let's see, 13. Okay, all right, so we do have a change in the structure of this storm, all right? This is the RFD with the heavier precip in this area. That's called the forward flank. When we look at the ZDR, on the leading edge of that forward flank, we are getting a higher ZDR value starting to show up. The CC, cross correlation coefficient, is around a 1, so that verifies that we're getting some drop size distribution changes in this forward flank area of the storm, which means we are now starting to see storm evolve into something that could produce a tornado, given X amount of time. In other words, the structure is getting better organized. So that's a precursor to let you know that the mesocyclone is now going to increase. Doesn't necessarily still mean a tornado yet, but it means that the storm is now in a better position to do so going forward. So we'll see what happens over the next 5-10 minutes and see if that trend continues. Now this one has some hail. All right. Remember earlier I was telling you that the pink was too low to the ground. They didn't really have very strong updrafts, and now this one finally does. So that's already a significant change. So I can strip away the light stuff, right? So let's see what my value is. 63 dBz is where this is. So this is a good indication of golf ball size hail or slightly larger. All right. So you can see how now that hail core aloft is up around 30,000 feet. So the intensity of the storm has grown and strengthened to allow updrafts to continue to carry those hailstones higher and higher. The rotational characteristics, however, are still mid-level based, high-level based. It's not quite down low enough yet. All right, let me see what I can do with the winds. Yeah, there's just no significant rotation yet. So, what I'm going to watch for is if this is our core center circulation trying to get going, we're going to watch for these red colored values to come in and swing around here in the back end underneath here toward Fairview. All right. So as our intensity increases on the circulation side, that's usually what happens. All right. Probability of a tornado is only 8% though, so we shall see. I wonder if there's any leftover outflow boundaries in this area from prior storms. So let's animate that and take a look. There was obviously a good boundary here. There was something here that kept firing additional storms. You see that? I don't see anything. All right, I don't see anything in the environment that it can interact with from residual stuff from before. So since I don't have any strong rotation centers yet, we still have a little ways to go before this storm would try to produce a tornado. I have a vague, weak signature here, and that's it. Now things can change quickly when it comes to damaging winds, but as far as the tornado generation goes, that's still many, many minutes away, if that even happens. But there's been some changes in this storm, at least going toward that direction. It's just going to be a while. So what I'm going to do is I'm going to sign off so you can take a break, get some things organized, and then I'll do another live. Hopefully Facebook doesn't mess me up. So that's okay. We can work through it. It's a little stress, no big deal. All right, guys. Hey, thanks for tuning in on this first version of storm coverage. The next time you see me, it's probably going to be because of tornadoes, and then we'll just kind of keep covering those. And it looks like a long afternoon and a long evening. So, if you have stuff to do here in the metro Oklahoma City, looks like things are good for the first part of our afternoon. Most of the models don't bring anything here until late afternoon. All right, so they're all out west first, and then they move in. So it gives you at least a little time to get things done. But I can't promise you an hour window. Just can't do it, unfortunately. It's not that type of an event. But I'll keep watching it for you. Thanks again for tuning in, liking and sharing the video, and we'll be back again. Take care.